My name is Z. I'm a software engineer at NEO, so I'm colleague of those people who organize this conference. Most of the time I'm based in Singapore, so thank you for having me here today. Today I'm going to talk about IndexedDB, and how many of you have heard of IndexedDB before? Cool. How many people actually use IndexedDB before in production code? Nice. Will you use it again? So my talk today is about IndexedDB, and hopefully it's going to be useful for you guys. So our story with IndexedDB started when one of our clients came to us to develop an inventory system. So this client is a company in oil industry, and they have people working in remote places with, intermittent internet connections, like here, I guess. So like remote island in Indonesia, in Iraq. And so one of the must-have features that they ask for is that the applications need to work offline. So we came up with a design somehow. We're going to have a server running Rails and Postgres in the US, and then we have our user using applications with JavaScript and in-browser storage in remote places. So when the internet is on, they will be able to sync the data from the server to the in-browser storage. When the internet is off, users should still be able to make changes to the database, and the database, the changes going to be persisted in the browser. When the internet get back on again, all the clients going to sync their changes to the server side. The server going to merge all the changes, come up with a mixture of green and blue, maybe yellow here. So, and then the client sync back with the server again and get the updated applications. So at that time, we didn't have a lot of experience with offline storage, and we did a little bit of research to see our options. And so basically right now, you can either use WebSQL or IndexedDB. So WebSQL is SQLite in-browser implementations. It comes with a synchronous API. You can use SQL queries to query your data. It has been deprecated by W3C in 2010, but still it's supported widely in Chrome, Safari, Opera, and most mobile browsers. On the other hand, IndexedDB is new. It has been chosen by W3C to be the future of the web storage. It's come with an asynchronous API for now, and you use indexes to query your data. It's new and evolving spec, and right now it's only supported by Chrome, Firefox, and IE. So how many of you consider yourself SQL people, like relational database? How about NoSQL? Cool. So do you guys hate each other in any way? Because, because on the internet, you guys do, and so from our research, we find out that the decisions of abandon web SQLs to go for IndexedDB is actually controversial. The SQL people argue that SQL is much more familiar with web developers. Some even go further and claim that NoSQL is totally inadequate implementations for most kinds of complex application data. I'm not with them. Some people claim that that decision is political rather than technical. So it's kind of discouraging to see this kind of debate online. On the other hand, we have a long vision for ops managers, and we don't want to base our applications in a duplicated technology. So we chose to go with IndexedDB in the end. And I would like to show you a demo of IndexedDB today. Right. Okay. So this application is supposed to work for oil industry companies. So there's a few words that doesn't make sense to you. Please ignore them. delete all the database, all the record in the database, and try to use some beer name. So maybe that makes more sense to Scottish people. So right now, I just came to Edinburgh office and create an inventory for them. And you have the name or the name of the beer right here with the quantity of the beer is right up here. There's a button next to this that, let me try if I can change the size of the window. Not really. Anyway, so the application is supposed to work offline. So without the network, you can see my Wi-Fi is off. Not really, you can see that. But my Wi-Fi is off, and I refresh, and the application still loads and works as normal. I don't know how to. Just a second, please. The green button? Oh, right, cool, thank you. So, first of all, now I'm offline, and I create a few changes. I change the quantity here into like 100. So, there's a change that had been created in my IndexedDB, as you can see in the resources tab of the developer tool. You can see it here, in this particular object store with a key and particular object. So you can see that the change hasn't been synced yet. But now if I go online, wow, now I don't even know how to get online. Maybe it makes more sense if I show you guys another version of the applications which has been which is open in Firefox instead. Don't see my mouse anywhere. Right. So here, because it's offline, if I refresh, it's still load, but it's not going to change the quantity. And if I, add like 10 more of the same particular item, 100 more, then I have an unsynced change as well. Now, if I want to open my network, it's up here. And turn on my Wi-Fi. Hopefully this works. Yeah. I can try syncing the database right now. It's synced. This guy as well. So you can see that I get 200 right here. And that's how it's supposed to work for the applications right now. Yeah, that's enough for the demo. So my experience with IndexedDB has not been a smooth ride. And I think like now in retrospect, I think most of the problem I had was because I came from a relational database background, and I didn't really embrace the strengths and the weaknesses IndexedDB have. So, I mean, IndexedDB has its strength, or you can save JavaScript object directly, like just how I showed you guys just now. There's no rigid schema. There's a non-blocking asynchronous API that is very helpful when you want to develop responsive applications. And also it's more native to JavaScript because you don't have to work with yet another high-level language on top of your applications. Also, the learning stage for people like me from relational database background is not that steep anyway. So you have, So you have database, which has name and version, and it's contain one or more object store. Object store is like table in relational database, and it store key value pair. A key is like a primary key, which means it's uniquely identify a particular value. And like I said, there's no rigid structure, there's no columns, there's not a defined set of properties that you have to give to each of your object. There's index, which is a very familiar concept even in SQL database. It's organize your records of a particular object store based on the value of some common properties that all those objects share. And it's helped you to come up with fast lookup and filtering. Transactions is also a familiar concept. So in IndexedDB, a transaction has scope, which is the number of the object store that the transaction is going to work on, and has mode, which is read-only or read-write. And it has relatively granular log level on the object level, which means the transactions that are working on a particular object store, a read-write transaction is going to be blocked if there's other read-write transactions working on the same object store. This is actually a strength compared to Web SQL, because Web SQL actually locks the whole database whenever you do any read-write transactions. So just have a test of how it looks like to work with IndexedDB. So this is a snippet of code to add a beer object into your object store. And as you can see, because IndexedDB API is asynchronous, so you have to work with callback hell, as many people say today. So firstly, you open a database. I have a database named beerzas right here. So because it's asynchronous, you get back a request, and you have to listen to the onSuccess event on that request. Inside the onSuccess, you get back your database. And then from your database, you get the transactions, which here I pass in beer, which is the object store name, and read-write, which is a mode that I want my transactions to be on. Then I get the object store from that. Then I call the add functions on the object store, and then I listen to events on that particular request. So the code could be like complicated and long, as you can see. Another snippet, this one is about searching for beer with names starting from A to D, I guess. So I already omitted the part where you have to open the database, where you have to get the transactions, but still it's quite long to, firstly you have to define a key range where you define the upper bound and the lower bound of the range that you want to get the index, get the objects for. Then you start with a request, pretend that you already have the index name on the beer object store. You can actually open that index with that particular key range. Then you get back a request on success. You get back the cursor. If you get the cursor, it means that there's still value that match your query. And then you can get back the value right here. Do whatever you want with it. Continue. And the next value is going to be returned in the next onSuccess callback. So there's a few missing things for people from relational database. One is joins. Another is logical operators, and all. So all these have to be done manually, and can be tedious and slow. As you can see, like working with IndexedDB, sometimes the code can get complicated and long because of multiple callbacks. If you have one nested in the other, it's going to be complicated. But there's a few wrapper libraries to help you. YDNDB, then a few others. My favorite one is YDNDB. This is the snippet of code you can use using YDNDB to add a beer into that particular object store. So as you can see, at least in terms of length, this is much easier to understand. They also provide a few joy algorithm solver to help you with merging your result, which I think is quite interesting. So for us in Ops Managers, we use Backbone.js. So what we did was we wrote a Backbone IndexedDB adapter, and using it to put a layer of ORM on top of our data models. So here, to define a model class, you can specify the database name and the store name, and you can create a beer object like this, And instead of working with all the low-level transactions requests, you can just say save, passing in handlers for success and errors. There's a few roadblocks I feel when we work with IndexedDB. One is the bleeding edge. So IndexedDB is still evolving the spec. So within a few months, we were working on IndexedDB. The Chrome updates broke twice. So one of the lessons learned is always test in developer build, because after that, you still have a few weeks to fix it before it's brought out to your users. Another thing is about testing. So in Neo, we test everything because we don't trust our colleagues. So I feel testing asynchronous API is harder to write and slower to run. We are a fan of headless integration testing. We use Phantom.js and Capybara WebKit a lot, but IndexedDB is not supported by those drivers yet, so we still need to use like Jasmine and Selenium right now. It's harder to debug because everything that goes wrong actually goes wrong in the user browser. And without a logging system, it's hard to know the context of that bug. So we spent some time to develop a logging system to send us whatever wrong has gone in that browser. There's also data limit. So right now, our database is only around 2 megabytes, which is a long time until we had to worry about any of this. But so, just so you know, if you want to spend a lot of, store a lot of data in the local storage, then, Firefox, 50 megabytes or so until, and once you get the approval, you can go until unlimited. Chrome, 10%, but because it is 10% of available disk space, it means that when users keep storing stuff in the database, the allowance is actually shrinking, i.e. around 250 megabyte each applications. There's also no full text search. So if you have to do that a lot, then maybe you can consider WebSQL instead. So lastly, I want to show a few tips on IndexedDB that we find useful. The first one is managing version. So your applications is stored, like your application database is stored in user browser, which means whenever you upgrade your database, deploy some new versions in your server, you have to detect what versions the user their database is in and do the migrations. So in IndexedDB, when you open a database with a version number, it will return on upgrade needed if the current database is, the version is lower than the one you want to open in. And here, as you can see, I have two migrations. One is to migrate from version 1 from version 0 to 1. And another one is to migrate from versions 1 to 2. So be organized about this. Also minimize the number of transactions. Because we use ORM with Backbone.js, at first it's very natural for us to use one transaction per operations. So beer.save, use one transaction, beer.update, another transactions. But the thing about this is a transaction takes time to start and finish. So if you have two transactions, working on the same object store, consider using one instead. And also be aware of transaction locked to minimize the waiting time. Lastly, use index, because index is much faster for you to iterate through your data. Also, even more important, use different type of index, because different type of index helps different type of queries. A note for people from relational database background like myself, model your data based on your queries. Don't follow normalization. So an example about that. So here I try to get all the beer with particular style and the ABV, alcohol by volume, between 6 to 8. A naive way to model this data is to create two indexes, one on the style property and get a key range, which select only this value, and open a request on that index with a particular key range. Similarly, I can do one with the ABV property and select, let's set a particular range from 6 to 8, and open another request to select this value. And if I try to merge them manually, it can be slow because you can see there's 2 callbacks. They have to wait for each other. But IndexedDB comes with compound index, which is a good way to combine 2 indexes on the same object store. So here, instead of getting 2 indexes, I create 1 index on the style and the ABV properties. So all the values of that 2 index are going to be combined into arrays, and those arrays are going to be sorted. So if I set a key range from this particular L to 6 and L to 8, I actually can solve that previous SQL with only 1 index. Another example for this, select beer from all the brewers from Edinburgh. So if you normalize this into beer object store and brewers object store, it means that you have to do the join manually. But if it's possible, you can actually put brewer inside beer and create an index on the city property using the nested key path here, and then you can just select it in one go. Another one, this is not SQL for sure. Like for example, I'm new here and people actually recommend me a particular beer and I want to try it. I want to select all the bars that has that beer available. So a naive way to do it actually a good way to do it in relational database is to normalize them, have a beer object store, have a bar object store, and have beer bar availability, where you connect these 2 together, and wherever there's a beer and a bar, appear on the same row of this particular joy table, it means that it's available at that. This beer is available at that bar. However, as you can see here, if we're gonna do it this way, it means that we're gonna have to merge these 2 relations together, and it's gonna be slow in IndexedDB for sure. So another way to do it is maybe have a beer available as an array of all the names of the beer available at that particular bar. And so if we can create an index of type multi-entry, true. So this index is going to break down this array into each value. And for each value, it's going to map it to the key of a particular beer. Then we can select it in one go. Here, I set the key range to only get this particular beer name. In this particular index, I can select it. Or an even better way to do it is to put the list of all the bars that have that particular beer into the beer object. And there whenever you get that particular beer, you have the bars arrays available for you. Of course, denormalization comes with trade-offs. So firstly is overhead in inserting, updating due to data redundancy, because that, like a particular bar object actually appear in the different beer objects. So whenever I want to update, for example, my bar address, I actually have to update all that objects. Also, index takes up space, so if space is a concern. Another thing, using web workers. So if you really do intensive database operations, consider using web workers. Right now, IE and Chrome actually allow web workers to access IndexedDB. Also, synchronous API is coming only for web workers. So that's good. Maybe you can get rid of all that callbacks. That's my talk. Thank you.